Hello, this is Gregory Maxwell, and we are now going to be looking in this video, in this lesson, on linear inequalities in two variables. We'll talk about how do we graph the solutions to linear inequalities in two variables, and also we'll be talking about solving systems of linear equations in linear inequalities, with two variables, systems of linear inequalities with two variables. Now, as the screen shows, a linear inequality in two variables. Let's say the two variables are x and y, x for the horizontal value and y for the vertical axis. It's an inequality that can be written in terms of less than or equal to, greater than or equal to. Technically not equal to is also an inequality, but we don't typically involve those. And in a linear inequality, you must have a variable to work with. So you either have an x or a y or both in the inequality. In this case, we're talking about linear inequalities, so we're not talking about radicals or squares of variables and so on. We're talking about lines, straight lines, and we're only talking about two variables, so we're not talking about planes. We're only talking about straight lines in the xy plane. So when we talk about a solution to a linear inequality, we're talking about a point that satisfies both inequalities. So in this case, we are not talking about simply one point where two lines meet. We're talking about all points in a region that relates to what the inequality is saying. So in this case, if we're dealing with one inequality, we're looking at all points that satisfy the inequality and that therefore fall in the region of the graph that the inequality is describing. So let's go through the steps here. This information can be found in the book Intermediate Algebra. I'm using the second edition, Intermediate Algebra by Miller, O'Neill, and Hyde. And I'm using section 9.5 as the section that I'm using as my resource here. So when you're graphing linear inequalities, what you want to do is solve for y. This is very important. This helps with a lot of the analysis. So if you, of course, there's no y's in the inequality, just x's, then you solve for x, and then you have the boundary will be set by a vertical line. Otherwise, y will be in the inequality, and you can solve for y. Once you've solved for y, you need to analyze two things. First, you have to analyze whether the line that you draw to represent the equation, the inequality, the line for the corresponding equation, is that line a dashed line or a solid line. Because what we're going to do is we're going to solve for y and graph the equation of the corresponding line. If the inequality is a strict inequality, that means if it's only a less than or only a greater than, you will draw a dashed line. It's kind of like what I underlined here with. However, if the line is a less than or equal to or greater than equal to, then you draw a solid line. A dashed line says that the points on the line are not part of the solution, and a solid line says the points on the line are a part of the solution. It's kind of like the distinction between an open circle, and closed circle. Open circle says the end point is not part of the solution. Closed circle says the end point is part of the solution. Similarly, a dashed line says the points on the lines are not part of the solutions, and a solid line says the points on the lines are part of the solutions. Once we've determined what the line looks like and we've drawn the line, now we have to decide whether we're going to shade, where we're going to shade. Now, if you have y is greater than the inequality, then you shade above the line, because you're saying the solutions are for y values that fall in the region above what that line. And then if y is less than the inequality, then we shade below. If there's no y in the inequality, then you'll shade either to the left for x less than the value or to the right for x greater than the value. Otherwise, we focus on above and below. To illustrate what we're doing here, let's do these two examples that I have here on the screen. We have 2x plus y is greater than or equal to -4. Step number 1, solve for y. So we're going to subtract 2x from both sides. So we end up with y is greater than or equal to -2x minus 4. So we're going to graph the line whose slope is -2, which I'll write as -2/1, and whose y-intercept is negative 4. It crosses the y-axis at negative 4. So we go to negative 4 on the y-axis, and then we go down 2 over to the right one, or go up 2 over to the left one, because again it's a negative 2 over 1, or you could write it as 2 over negative 1. So the slope of this line is negative 2, and the y-intercept is negative 4. Now, since this line here is since this is a greater than or equal to, we know that the line we're going to graph is a solid line because the points and the lines are part of the solution. All right, now we're going to draw that line. I'm just going to use a red marker here, and we're going to see if we can draw through all those points there. And there we have the line. The next is we have to shade. Now, since when we solve for y, we get y greater than or equal to the expression. We're saying all the points that make this statement true are either on the line for the greater than or equal to, or above the line for the greater than. So we're talking about shading above the line. So we'll shade above the line for greater than. So I'm going to use a highlighter here. That means all the points in this region that I'm shading with this highlighter are solutions to the inequality. And that is how easy this process is. Now, please make sure I'm not shading on the left side, or below the line, I should say. I'm only shading above the line. And to decide whether it's you shade how to get to above the line, what you do is you just put your pencil on the line and then go directly upward, and then that will tell you what region is above. Now let's take a look at this one here. We're now gonna again solve for y, but this time when we're solving for y, we have to divide by negative 3, which means we have to reverse the inequality. Divided by negative 3 is the same as multiplying by 1/3, so the inequality is negative 1/3 x. So we're talking about a line whose slope is negative 1 over 3, and the y-intercept is 0. This line is a dashed line because it's a strict inequality. And we're going to also shade above this line because, again, when we solve for y is greater than the expression. So we're going to shade above again. So let's start. We start at 0, 0, and then this says go down 1 over to the right 3. Or go up 1 over to the left 3. And then we graph our inequality. We graph our corresponding line. Now, as you can see here, this, as it says, is supposed to be a solid, dashed line. So what I'm going to do is I'm just going to make this into a dashed line right there, so that you can see that this is not supposed to include certain values. So it's a dashed line. And then we're going to shade above the line. So I'm going to shade the region above the line right there. And there we have it. All points in that region that I'm shading are solutions to that inequality. And to illustrate what we're talking about, if I take a random point in the shaded region, it should make that inequality statement true. Let's go back up here to the first example. Let's say I choose this point 0, 3. That means when x is 0, y is 3, the inequality gives you a true statement. 0 times 3 is, 2 times 0 is 0, plus 3 is 3. 3 is greater than or equal to negative 4 because positive numbers are greater than negative numbers. Let's try this one here. Negative 1, 0. I plug in 0 for y and negative 1 for x. I get negative 2 plus 0. That's still a greater number than negative 4 because negative 2 is to the right of negative 4. And you can see a similar result in the second inequality. So here's another example. Again, just a summary of the explanation. You solve for y, you graph the related equation and use a dashed line if the inequality is strict, and otherwise if it's not a strict inequality, if it's just an equals bar, then you use a solid line. And then shade above, if when you solve for y, you get y is greater than the next expression. And if it's not, if it's y is less, you shade below. So let's do a few examples. Let's start off with this one here. 5x minus 2y is less than 10. So first we're going to solve for y. So we have 5x minus 2y less than 10. We subtract 5x from both sides and then divide by -2. And what happens then is the inequality reverses and we get 5 over 2x minus 2. So y is greater than 5 over 2x minus 2. So the slope of this line is 5 over 2. The y-intercept is -2, or the point 0, -2. We are going to use a dashed line because that's a strict inequality. And we are going to shade above because the y is greater. We'll have other examples where the y is less, and we'll see what happens there. So I start off with the point -2, 0, -2, and then I go up 5 to the right 2. 1, 2, 3, 4, 5 to the right 2. Or I go down 5. 1, 2, 3, 4, 5 to the left 2. And there we have it. And then I'm going to draw a dashed line joining those points. So now, since I'm drawing a dashed line, I need to make sure that I create some gaps on my little line here to indicate that it's a dashed line. And then, according to the greater than, I shade above. So I start here and I go straight up, and that tells me the region. It's the region that seems like it's behind the graph right there. It's actually above the line. So all points in this region are solutions, and you can check, as I said, by just choosing a random point in the shaded region and then see if it falls into the it makes the statement true. So let's say we try -3, -2. 5 times -3 is -15. -2 times -2 times -2 is +4. -15 plus 4 is -11, which is of course less than +10, and that's an indication that we are on the right track. Then let's go to the second example here. Once again, we're going to solve for y. 2x is less than or equal to -6y plus 12. To solve for y, I'm just going to do this. I'm going to add 6y to both sides, and I'm going to subtract 2x from both sides. And what that will do is give me 6y is less than or equal to -2x plus 12. And then when I divide by +6, I just keep the inequality. So I get -2 over 6 is -1/3 x plus 2. So we know then that the slope is -1/3 and the y-intercept is 2. So let's see, we're going to have since it's a less than or equal to, we're going to have a solid line. And we're going to shade below that line because y is less than. So we're going to shade below the line, shade below. So let's see what that looks like. We start at +2. Then we go down, since the slope is -1/3, we go down 1 to the right 3. We can do that over and over. Down 1 to the right 3. And there's no more point in the graph that allows that. So we're just going to have to stick with that. And then we just draw our best line. And there we go. We have a line there. And then it says shade below. So we start on the line and go below the line. So I'm talking about down underneath the line here to the bottom of the line, because we're talking about y values that are below. Now I made a little bit of an error there, a little bleed over of my graph. And so I'm just going to erase that little extra zone there. just so that it doesn't seem like I'm shading into the wrong region. All right, so that is my solution. So if I choose a point 0, 0, it will make the statement true. When y is 0, we get 12, and x is 0, we get 0 on the left side, and of course 0 is less than or equal to 12. There we go. Now, let's go on to this next example here. Very simple. I just divide both sides by 2. I get negative 3x is less than y. Or we can say y is greater than negative 3x. So we know that the slope is negative 3 over 1 and the y-intercept is 0. So let's see, what type of line do we have? We have a dashed line because it's a strict inequality, and we're going to shade above the line. Shade above. So we graph the corresponding line, the line for y equal to negative 3x, and then since it's a strict inequality, we'll draw the line as a dashed line. So that means go down 3 to the right 1, or go up 3 to the left 1. And then we're going to draw the corresponding line. And we're going to make it into a dashed line. And then we're going to shade above the line. So I choose a point on the line and I just go up into the air, and there we go. It tells me that I'm on the right side, effectively, of this line. So over and over we see that these multiple examples is the same process. Now I'm going to do one quick example with a vertical line so that we can see that it's not much of a difference here. In this case, we only have an x in the equation, so we solve for x. So x is less than 5 over 4. And what we have is a vertical line. This line is a vertical line. Now that means it does not have a slope. It's an undefined slope. But we still know that the line is going to be dashed because it's a strict inequality. But in this case, since x is less than 5/4, we don't shade above or below here. We shade to the left or to the right. In this case, we shade to the left of the line because the x values are less than. And 5 over 4 is actually just 1.25. So I just choose 1.25 on the line. It's approximate here. And I draw the line for 1.25. A vertical line going through the x-intercept 1.25, and then I'm going to make that into a dashed line by just taking out pieces of it so that it appears to be dashed. It ends up being dashed, and then since it's x is less than, we shade to the left. And that's how we do that. Now, let's move on here to another example. And finally, I'm doing these examples only because it's it's with decimals. And you will see that it's basically the same process. You solve for y, so we're going to subtract 0.1x from both sides. And then we divide by 0.2, and when we divide both sides by 0.2, since we're dividing by a decimal, we are a positive, sorry, we keep the inequality. Negative 0.1 divided by 0.2 is half, and 0.6 divided by 0.2 is 3, and there we go. So then we have slope is 1 over 2 and y-intercept is 3. And then we know that this line is going to be a solid line. And we also know that we are going to shade below the line. Very simple. Now, let's put our information. Y-intercept is 3, slope is up 1 over 2, which we can do repeatedly, up 1 over 2, up 1 over 2. Can even go down 1 to the left too. It's the same deal. And we're drawing a solid line here because there's a less than or equal to. Well, and if it's a less than or equal to, then we're shading below the line. I start on the line and I shade below. And there we have it. That's how we solve the equation of solve a linear inequality in two variables by graphing the solution set on the coordinate plane. Let us now go on to solving systems of linear equations in two variables. Systems of linear equations in two variables. Now, solving systems of linear equations in two variables is basically following the process of solving a linear equation, one linear inequality. Let me start over. Solving a system of two linear inequalities in two variables is the same as solving a system of an inequality in two variables, but looking at where regions overlap or intersect. So we have basically two cases here. We are either going to solve a system where the two inequalities are joined by the word and, or we're going to solve a system where the two inequalities are joined by the word or. And so let's deal with case one. Case one is when we have an intersection, and that is indicated by the word and. And if they don't say that it's an intersection, or the word and or is not indicated, then the word and is what we're thinking of. It's an intersection. And basically what we're doing is graphing the inequality, both inequalities, and seeing where the two regions intersect. Where the regions intersect is the solution of the system. If we're talking about a union, that is indicated by the word or. The word or must be used for us to be dealing with a union. Otherwise, we have to assume that it's an intersection. And the solution is not where the two regions overlap only. It's the all regions that would normally be shaded. So let's take a look at these two examples. I have x is less than 0 and y is greater than 2. What I'll do is graph x is less than 0, which is the graph of x equal to 0, which is the y-axis. It's a dashed line because this is it's just a strict less than, and we're shading to the left. So normally we'll be shading to the left of this pink line on the graph. Now when we go to the other graph, it's y greater than 2, which is a horizontal line, and since y is greater, we shade above. It's a dashed line because it's a strict inequality. So we'll be talking about shading above for the second line and to the left for the first line, and where those two regions intersect is in that little box there. That is the solution set to the solution to the inequalities, the system of inequalities. Now again, we have a similar situation down here. The difference is we're using the word or, and we're talking about less than or equal to in both inequalities. So the difference is when we draw the lines, we're drawing solid lines instead of dashed lines. And secondly, when we're shading now, we're not only looking at where the two regions intersect. Any region that would normally be shaded for one line or one inequality would be shaded. So we're shading all of the region to the left of the vertical line and all of the region above the vertical line, and that creates that region that is indicated here on the graph. So let's do a few examples. If your inequality is not already written as in slope-intercept form, we're going to do that. Since we're talking about two inequalities here, we're going to label both of them and solve each inequality individually, graph them, and since there's no indicated connector here, we're going to assume that we're looking for an intersection. So inequality number 1, we're going to solve x minus 3y greater than 3. We're going to solve that for y. So I'm going to subtract x from both sides, and then I'm going to divide by -3. So we end up with y is less than 1/3 x minus 1. And remember, when you divide by a negative, you reverse the inequality. For line number 2, the inequality is already in the format that we want, so we don't have to do any rearranging. So for this line here, we know the slope is 1/3 and the y-intercept is -1. We know it's going to be a dashed line because it's a strict inequality, and we know that we're going to shade shade below the line. For this one here, the slope is -2/1, the y-intercept is 4. We know we're going to draw another dashed line, and we're also going to shade below for this line because it's also less than the expression. So for the first line, let's see how we do that one. For the first line, I start at -1, then I go up 1 over to the right 3, or I go down 1 over to the left 3. And then I'm going to draw a line to that. Well, let me use green for this one here. And then I will draw I will just create a little set of spaces here so that we see the dashed line. Then this would be the line for line number 1. So let me just put a little 1 here to remind me that's line number 1. Now let's do line number 2. We're starting at 4, and the slope is -2/1. So I go down 2 to the right 1, and I can do that repeatedly. Down 2 to the right 1, down 2 to the right 1, and I can do it again. Down 2 to the right 1. And this time I'm going to draw that line with a blue line. No biggie. And then we're going to make that a dashed line by creating spaces there. We call the point where the two lines intersect the vertex of the region. So just like the vertex of a polygon, that's what we're talking about here. Now in this case, I'm going to do something a little bit tricky here. Just to help us to follow along, you can do this in the initial practice so you get an idea. For the first line, it says shade below. So I'm going to go to the first line and shade below. But instead of actually shading, I'm just going to put a series of dots of where I would normally shade, because I'm going to look at something particular. And then for the other line, it says shade below. So I'm not going to shade as well. I'm just going to put a series of dots to represent where I would normally shade. And then where I have the two same set of dots, that's where my region is. So now I'm going to come to that now, and I'm going to shade where the two regions overlap because it's an intersection. So my solution set are all the points in this shaded region right here. And I'm going to shade it a little darker so that it's very clear what region we're talking about. Now again, that little trick I did with the dots is not an absolute necessity. It's just to help us to find the shaded region. And I'm just going to erase this little bit right here so that it doesn't appear to be part of the solution set. And there we have it. Now let's take a look at this set here. In this case, we're dealing with an OR situation. That means we're looking for whatever region is shaded. In an AND situation, we're looking for an intersection. In an OR situation, we're looking for whatever region is shaded. So I'm going to solve for y here. I get y is less than or equal to 2. and for here it's already in the right format. So in this case, this is a horizontal line because there's no x in the equation. It's a horizontal line. It's a solid line, and we're shading below the line because this y is less than. In the other case, we are going to talk about slope of 1, and we'll write it as 1 over 1. The y-intercept is 1, and it's a solid line, and we're going to shade below this line. So let's look at what this looks like then. So I take my line. I know I'm going to shade, the line is line y equal to 2x. So that's the line there. And then the other line is start at the point 1, 1, and then use the slope up 1 over 1 repeatedly to make sure we get a good set of lines. And then I'm going to draw a solid line. This one I'm going to draw as a green line here. And then doing my little trick, since this is an OR, actually any region that would normally be shaded gets counted. So this one is shade the regions below, and this one shade the regions below. So all the regions that would normally be shaded, because there are, we get those guys. So we're talking about this region in this little space here, bottom left, then bottom right zone, and then we go up to the top. Right zone right there, and that's our solution set. Now with this one, relatively easy. We have ourselves a vertical line. In reality, that's the y-axis. And we're going to draw the solid line. And we're shading to the left of this line because you can't shade below a vertical line. And then with this one, we have a horizontal line, and in reality, that's the equation of the x-axis. And in this case, we are going to also still have a solid line because it's less than or equal to, and we're going to shade below the line. And since it's an and situation, we look for the intersection. I'm not going to do the dot situation here. I'm just going to do the answers here. So since we're dealing with two solid lines here, one is the y-axis and the other is the x-axis. So that was the second line, and this was the first line. And we're shading the region that's both to the left of the x-axis and at the same time below the y-axis. To the left of the x-axis and below the y-axis. That's that region at the bottom left of the grid, which is this region right here. It's an intersection of those regions, so we just shade that quadrant, and that's it. As you can see, this experience is relatively easy, but it does take some practice. Let's do a few more of those types. Again, these are systems. These are systems where they don't tell us whether it's an and or an or, and if they do not tell us, we have to assume it's an and so they were looking for an intersection. For inequality number 1, we solve for y. So we end up with negative 5y less than or equal to negative 2x minus 10. And then y is greater than or equal to 2/5 x plus, oh, this was a plus 10, sorry, -2. 2 + 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 = -2. 2 - 10 And then for the other inequality, we have 3x minus 2y greater than 6. And we solve, we get negative 2y is greater than negative 3x plus 6. And then y is less than 3 over 2x minus 3. So what we can see here is we can tell the slope on the y-intercept. We know that this line is a solid line, and we are going to shade above. This line is a dashed line, and we're going to shade below. And we're looking for the two regions where they overlap. We're looking for an intersection. So let's draw those lines. I'm starting with this first one on the left. Negative 2 is the y-intercept, and then the slope is up 2 to the right 5. I could also have gone down 2 to the left 5. And then I would draw a solid line joining those regions, those points, or going through those points. Almost had it. Then we have the next line here is starting at negative 3. We go up 3 to the right 2. And I can just keep doing that, up 3 to the right 2. And that's probably all the time I can do it. And then I'll just draw that one with a green line. Not quite right. Up 3 to the right 2. So let's see if we can adjust this to make sure that it passes through the right region here. There we go. Then I'm going to make it into a dashed line. Now, as you can see, one of the lines is dashed and the other one is solid, because one of them is a strict inequality and the other one is not. Since we're talking about where the two regions overlap, let's see if we can figure it out without doing the dots. This one here is y is greater than or equal to 2/5 x. So greater than means we're shading somewhere above the region here. And this one we're shading below the dashed line. So we're shading above the solid line at the same time below the dashed line. That's in that little region right there. Below the dashed line and at the same time above the solid line. And that's my solution. Let's go on to this next example. Again, in this situation, we are going to look at where the two regions overlap. In equation number 1, we solve for y. And we end up with negative 5y greater than or equal to negative 4x minus 20. We don't end up with that. Once we do the next step, we end up with our answer. Y is less than or equal to 4/5 x plus 5. Plus 4, sorry. And for equation number 2, it's just a vertical line. So remember, this is a vertical line. This line here, we have a solid line. Both of the lines are solid. And we're talking about shading below. And in this case, we're shading to the right of this solid line. And again, since there's no indicating word, we're looking for the intersection. So I'm going to draw my first line and my second line here. X is greater than or equal to negative 3. I'm basically just going to draw a vertical line that passes through the x-intercept negative 3. And then for this one, I start at 4 and I go up 5 over 4, but I can't do that, so I'll just go down 4 over 5, which is basically this line here. And that's also a solid line, so we have ourselves a graph. Then I shade the region that satisfies the conditions. It is below this line here, the first line, and to the right of the vertical line. So below the blue line and to the right of the green line. We're talking about this region right here. And there we have our solution to our system of inequalities right here. Now, let's go on to this last example of this set, and then we have one quick little application concept to look at. In this case, we're dealing with an OR situation, so we'll shade all corresponding regions. I'll solve this inequality. Negative y less than or equal to negative 2x plus 2 divided by negative 1. I get y is greater than or equal to a positive 2x minus 2. So we're talking about a solid line and we're going to shade above. And in this case, I'm going to solve for y. I'm going to go 3y is greater than negative 2x plus 6. And then I divide by 3. I get y is greater than negative 2/3 x plus 2. So we're talking about a dashed line here. And we're going to shade above. But remember, in this case, we're going to do it with an OR, so we're talking about a union of the regions. So let's start off here. For this one, we could start at negative 2, and our slope is up 2 over 1, which we can do multiple times. Or we can start at a point and go down 2 over to the left. And then I'll draw a solid line joining those pieces together. And then let me just adjust my line here to make sure that we have a good enough graph. And then this one, we're going to start at 2 again, at positive 2 this time. And then we're going to go down 2 to the right 3. Or we'll go up 2 to the left 3. And then we'll draw a dashed line to match that. Let me draw it with a green. Oh, didn't select. So now I'm going to make the second line, the green line, into a dashed line because it's a strict inequality. And then we see where the regions overlap. We're shading above the solid line and above the dashed line. Above the solid line and above the dashed line. That's this region right here. Above both lines. If you check out the other regions, both won't be above only one of them would be or neither. So for example, in this region here, they're below the green line and above the blue line. Here you're above the green line and below the blue line, and in this case you're below both lines. To check one point in the system, let's just, oh, I'm sorry, we're not doing overlap, we're looking at union. So I'll shade above both lines. So I'm going to shade above the blue line. And we're going to also shade above the green line. Now the reason I have to make this adjustment is because it's not an intersection, it's a union. So where you would normally shade for each graph is where you shade overall. So all the regions get shaded except for the region that doesn't work for either one. which would be the region that's below both. Now let me just take a quick look at the intersection here. If I choose, let's just choose one point here. Let's choose this point 4, 1. If I plug it into both equations, the inequalities will work. 4 times 2 is 8, minus 5, that's less than 10. 3 times 4 is 12, minus 2, that's greater than 6. 4 12 minus 2 is 10. So that point fits the conditions for both inequalities. And that's what we're talking about. It works for both. Last 3 questions, it says graph the feasible region. And the feasible region is simply a region, well, let me read it from the graph here. When two variables are related under certain constraints, a system of linear inequalities can be used to show a region of feasible values of the variable. So a feasible region are points that represent where the possible solutions to a system could be, possible answers that satisfy the conditions that are given. And the conditions that are given here are simply represented by inequalities. So let's start off with this one here. Basically, we're going to be graphing 3 lines and seeing where what region where all inequalities overlap. First line, x minus y less than or equal to 2. Solving, we get negative y is less than or equal to negative x plus 2. So y is greater than or equal to x minus 2. And then the other region is x is greater than or equal to 0, and y is less than or equal to y is greater than or equal to 0. If you look at this, you can see then that this is to the right of the y-axis, because that's the line for the y-axis, and this is above the x-axis. So we're looking in the first quadrant. We're talking about the first quadrant here. We'll call it quadrant 1. And then this is just the line where we're going to draw a solid line and shade above. So we're looking at a region that is in the first quadrant above this line. So let me draw my 2 regions here. I get x-axis, y-axis, and then my line, I start at -2, and then my slope is 1, so I go up 1 over 1, up 1 over 1, up 1 over 1, and I just keep doing that till I run out of space on the graph. And then I'm going to draw my line here, and we're looking at the region above the x-axis, the region in the first quadrant that is above this line. So we're talking about all the regions up here, but only in the first quadrant. And the quadrants will also count. So we're in the right stead right here. And there we have it. That's your feasible region. Any point in that region satisfies the conditions. Now, let's take a look at another example here. So we have y is less than half x minus 3, x is less than or equal to 0, and y is greater than or equal to -5. So of course this is the y-axis. This is to the left of the y-axis because it's less than. And this is above the horizontal line. And of course, those are solid lines. In this case, we have a dashed line. And we're going to shade below. So let's see what we can graph with this one. I'm going to draw my y-axis as a solid line. Oh, we'll have to move that over a bit. And I'm going to draw the line y equal to -5 as a solid line again. And then I'm going to draw my line here, 1/2 x minus 3. Start at -3 and I go up 1 over 2, up 1 over 2, or I go down 1 over 2, down 1 over 2. And then I join my line, but this line is going to be a dashed line because of the strict inequality. So I'm going to create a dashed line here. All right, so where are we going to shade? We're going to shade to the left of the y-axis. That means we're going to shade on the left side here. We're going to shade above the line y equal to -5. That means we're shading above. That means we're in this region here. And we're going to shade below the line. So it's in that little triangle right there. And there we have our region. Just a space in that little triangle is where we shade. That's our feasible region. And of course, where two of the lines intersect, it's called a vertex. Now we have a big one here. This one I'm not going to show all the work for. I'm going to indicate that this is the first quadrant because it's above the it's to the right of the y-axis and above the x-axis. So that's quadrant 1. Then let's talk about what these two regions are. We're looking at an intersection. We have x plus y is less than or equal to 5. That means y is less than or equal to -x plus 5. And then we have x plus 2y is less than or equal to 6, which means y is less than or equal to -half x plus 3. When you solve that equation, you will see how that works. So we're talking about a solid line in both cases. And in both cases, we're shading below the lines. So let's start looking at what we're dealing with. We do our first quadrant. Let's cordon that off. Quadrant 1 is cordoned off here, and again I have to move my line over just to make sure it fits. Then I'm going to graph this line, -x plus 5. So the y-intercept is 5, slope is -1. So we're talking about this region right here, and that's a solid line. So I'm just going to draw a solid line. Nope, made a little error there. So that's one line, and then the other line we talk about starting at 3, and then slope is -1/2. So we go down 1 over 2 each time, down 1 over 2. And we can also go up 1 to the left 2. But of course, the region that we care about is in the first quadrant that satisfies the conditions. So I join my points together, and I think that's a good enough graph. So let's start looking at where we shade. We're shading somewhere in the first quadrant that is below both lines. So it must be below this line and at the same time below this line in the first quadrant. So it cannot be this region little piece right here because it's above one of the lines. Can be this region here because it's above one of the lines. Can be this region here because it's above both lines. and it has to be this region because it's both below both lines in the first quadrant. So the feasible region is this region right here. Now the other regions that I didn't mention are disqualified because those are not in the first quadrant. This says only the first quadrant we're looking at, and this part I'm shading is the only part that fits both conditions. That brings us to the end of this lesson. Seems like a short lesson, simple, short concept, but we spent quite a bit of time doing a number of examples. I strongly recommend that you look over these examples carefully and try them on your own. And also, as always, I recommend that you do the practice questions on Khan Academy. And you can go to your textbook or any math textbook, and you can find a math textbook for an intermediate algebra and college algebra textbook on openstax.org, openstax, OPENSTAX.org, or you can download the app onto your phone in Android or Apple. All the best, keep practicing, and remember, study, review, memorize, practice for good learning in mathematics. All the best.